Bismillahirrahmanirrahim. Question number 6. If bz plus c over b minus c equals to cx plus az over c minus a equals to ay plus bx over a minus b, then a plus b plus c into x plus y plus z equals to ax plus by plus c z we have to prove. For this, let this is equal to k. So the everyone individually will be equal to k. Take it. So we can write it as bz plus cy over b minus c equals to k. Cx plus az over c minus a is equal to k. And ay plus bx over a minus b equals to k. Now multiply this b minus c here with k. We get bz plus cy equals to k into b minus c. Here cx plus az equals to k into c minus a, and here ay plus bx equals to k into a minus b. Further, we can write it as bz plus cy equals to kb minus kc. Here we get cx plus az equals to kc minus ka, and here we get ay plus bx equals to ka minus kb. Now look at here, bz cy, so ax is missing, so add ax on both sides. Or say this is 1, this is 2, this is 3. Add ax on both sides of equation 1. So what we get? Ax plus bz plus cy equals to ax plus kb minus kc. Say this is equation 4. Here, look at here, cx az by is missing, so add by on both sides of equation 2. So we get by cx plus az equals to by plus kc minus ka. Suppose this is 5. And look at here, ay bx cz is missing, so add cz on both sides of equation 3. So cz plus bx plus ay equals to cz plus ka minus kb. Say this is equation 6. Now add 4, 5, 6. Equation 4 plus equation 5 plus equation 6. Left side with left. So first of all, I am going to add the left side. So here ax bz plus cy plus by plus cx plus az plus cz plus bx plus ay equals to, now the right side, ax plus kb minus kc plus by plus kc minus ka plus cz plus ka minus kb. Now look, this kb cancel with this kb, kc cancel with this kc, and ka cancel with this ka. What remains here? Ax plus by plus cz. And look at here on the left side, this is ax, this is bx, and this is cx. So take common, so we get x plus y plus z. Now look, this is by, this is ay, and this is cy. So take y common, so b common, so we get x plus y plus z. Now look, this is cz, here is cx, and this is cy. So take c common plus c, so here we get x plus y plus z equals to, on the right side here remains ax plus by and plus cz. Now take x plus y plus z common, x plus y plus z common. Here remains a plus b plus c, which equals to ax plus by plus cz. Or we can write it as, first write a plus b plus c, and then write x plus y plus z equals to ax plus by plus cz. Proved. We have proved the result, required result. In the book question, this is az, but it is actually ax, so make correction in your book. Now question number 7. If x over b plus c minus a equals to y over c plus a minus b equals to z over a plus b minus c, then b minus c into x plus c minus a into y plus a minus b into z equals to 0, we will prove. Solution, let this is equal to k. So take every one individually equals to k. So we can write x over b plus c minus a equals to k, y over c plus a minus b equals to k, and z over a plus b minus c equals to k. Further we can write it as x equals to, multiply this with k, we can write it as b plus c minus a, and this we can write y equals to k c plus a minus b, and we can write it as z equals to k a plus b minus c. Now x equals to, multiply k, we get kb plus kc minus ka. Similarly, y equals to kc plus ka minus kb, and z equals to ka plus kb minus kc. Now according to the question, we are going to prove b minus c is with x, so here multiply b minus c on both sides. For this, first say this is 1, this is 2, and this is 3. Multiply b minus c on both sides of equation 1. Multiply b minus c on both sides of equation 1. So here b minus c x equals to b minus c into kb plus kc minus ka. Now multiply. Here we get kb square plus kbc minus kab, and now multiply c here, we get minus kbc minus kc square, and minus into minus plus kac, and this is b minus c x. Say this is equation 4. Similarly, multiply both sides of equation 2 with c minus a, and both sides of equation 3 with a minus b. C minus a on both sides of equation 2, we get c minus a y, and when we multiply this with this, we get equation 5. And similarly, a minus b on both sides of equation 3, so when we multiply a minus b with the 3, so a minus bz, and when we multiply these two, we get this equation 6. Now add equation 4, 5, 6. For this, first add the left side. Left side of 4 is b minus c x, and of 5 is c minus a y, and of 6 is a minus b z, equals to. Now add the right sides, which are I am going to write. This is kb square plus kbc minus kab minus kbc minus kc square plus kac. Now equation 5 right side is plus kc square plus kac minus kbc minus kac minus ka square plus kab. Now the right side of equation 6, which is plus ka square plus kab minus kac minus kab minus kb square, and plus kbc. Now all these terms cancel with each other, and we will get b minus c into x plus c minus a into y plus a minus b into z equals to 0. Look, kb square cancel with kb square. This kbc cancel with kbc. Similarly, this kbc cancel with this. This kab cancel with this kab, and this one kab cancel with this. Similarly, this ka square cancel with this. Kc square cancel with kc square, and kac cancel with this kac. This kac cancel with this knc. And finally, look at here, we get 0, which is the required result. Question 9. If a minus b over d minus e equals to b minus c over e minus f, then show that this is equal to this. For this, we are going to suppose solution, let this equals to k. A minus b over d minus e equals to k. B minus c over e minus f equals to k. We can write it as a minus b equals to k d minus e, and here b minus c equals to k e minus f. A minus b equals to kd minus ke. B minus c equals to ke minus kf. Suppose this is 1 and this is 2. Multiply 1 by f and 2 by d. Multiply both sides by f of equation 1. F into a minus b equals to f kd minus ke. So we get af minus bf equals to kdf minus kef. Say this is 3. Multiplying d on both sides of equation 2. D into b minus c equals to d into ke minus kf. So we get bd minus cd equals to kde minus kdf. Say this is equation 4. Now add 3 and 4. af minus bf plus bd minus cd equals to, right side with right, kd minus kf plus kde minus kdf. This is kdf. So look, this kdf cancel with this minus kdf. Now take minus from these two common, minus b common. So here remains, this will become plus f and minus it will become d. When you take minus b common from this, it will become plus f and this will become minus d. And similarly take minus common from these two terms. So it will become plus cd and it will become minus af equals to, here take ef minus ef common, minus ek common. So what remains here? Here remains f minus d. Now shift this minus e and f minus d here. So and take also common minus from these two terms. So when we take minus common, it will become b into f minus d, and this will become plus cd minus af, and shift this minus e f minus d, minus e into f minus d here. How? Dividing both sides by minus e f minus d. So here remains k. Now this minus cancel with this minus. So what we get? b into f minus d plus cd minus af over e into f minus d, which is equals to k. Now look, this is equal to k. Look, this is equal to k, and we have supposed that this is equal to k. Say this is a and this is b. From a and b we have proved that the required result, that this is equal to this. Yes, we have supposed that a minus b over d minus e equals to b minus c over e minus f equals to k, and we have proved that this is also equals to k. So from a and b both are equal, we have to prove it.